Let's just jump right into it. Today, we're unpacking a massive misconception, something you've probably seen a million times in movies and on TV. This whole idea of zero gravity. We are going to completely dismantle what you think you know about it because, honestly, the reality of what's actually happening up there in space, it's so much more fascinating than the sci-fi version.
I mean, we've all pictured it, right? Imagine just floating around in your bedroom, but suddenly, there's no floor, no ceiling, up and down just completely vanish. Your phone is just drifting midair. You try to drink your morning coffee, and it turns into these weird, perfect little floating spheres right in front of your face. You've lost all your weight. This is what almost everyone calls zero gravity.
But here's the wild thing to start us off. True zero gravity? It practically does not exist, like anywhere in the entire universe. We kind of just expect that there's this magic gravity switch that gets flipped off once you leave the atmosphere, but the reality is entirely different. In fact, scientists rarely even use the phrase zero gravity. They call it microgravity or weightlessness. Because whether you're millions of kilometers away being pulled by the sun or just drifting somewhere deep in the Milky Way, gravity is almost everywhere.
Take the International Space Station, for example. It's floating roughly 400 kilometers straight up. You'd think they've escaped Earth's pull, right? Nope, not even close. Up there, gravity is still pulling them down at 8.7 meters per second squared. To put that into perspective for you, Earth's surface gravity is 9.8. So the gravity pulling on those astronauts right now is nearly 90% as strong as what's keeping you in your seat right this second.
So that completely shatters the illusion, doesn't it? It leaves us with this incredible mystery. If gravity up there is still practically as strong as it is down here, why in the world do astronauts float? Why aren't they just slamming straight down into the floor of the space station?
Well, it all comes down to understanding weightlessness. The astronauts aren't experiencing a lack of gravity. What they're actually missing is what physicists call the support force, or the normal force. Think about it like this. When you stand on the ground, gravity's pulling you down, sure, but the solid floor is actively pushing right back up against your feet. That upward push, that's what your body actually feels as weight. So if you just magically delete the floor, gravity is still pulling you down, but without that pushback, you suddenly feel totally weightless.
Which brings us to Section 1, the secret behind orbit.
Okay, so here's the actual mind-bending reality of what orbit really is. The International Space Station is constantly falling toward Earth, literally just falling, but it never hits the ground. Why? Because it's moving sideways at an absolutely staggering 28,000 kilometers per hour. As it falls down, its sideways momentum is moving so fast that the curvature of the Earth continuously falls away beneath it. It is literally falling over the horizon forever and just never quite catching the ground.
So it really all boils down to this one idea. Zero gravity isn't the absence of gravity. It is the experience of continuous freefall. Because everything inside that station, the ship itself, the astronauts, their tools, their snacks, it's all falling together at the exact same rate. Nothing is pressing against anything else. The floor is falling away just as fast as the astronauts' feet are falling towards it. That shared, endless freefall is what creates that magical illusion of floating.
Moving on to Section 2, Simulating Space on Earth.
Now, to actually train for this, scientists use these massive aircraft, affectionately and probably very accurately nicknamed vomit comets. These planes basically fly in these giant wild roller coaster parabolic arcs. They climb super steeply and then they just dive. And during that dive, everyone inside enters a state of freefall. For about 20 to 30 seconds, they get to experience pure, unadulterated weightlessness. Scientists can also simulate this just by dropping objects down these massive vacuum shafts called drop towers. Because, again, anytime you are falling freely, you become weightless.
Let's look at Section 3, your body in free fall.
Turns out, living without apparent weight does some pretty weird stuff to human biology. Without Earth's constant compression pushing down on your body, your spine literally stretches out. You can actually grow several centimeters taller in space. But since your body isn't working hard to fight gravity every single second, your muscles weaken super fast and your bones start losing calcium. Even your fluids, which normally pull in your legs, they shift upward. This causes a puffy face, completely messes with your inner ear balance, leading to some gnarly space sickness, and can even permanently alter your vision over a few months. That's exactly why astronauts literally have to exercise for 2 hours a day every single day just to survive the eventual trip back down.
And it's not just our bodies. Everyday physics goes totally bizarre up there. Without gravity pulling cold, dense air down and pushing hot air up, a fire doesn't flicker upwards anymore. It turns into this weird floating blue sphere. Water doesn't pour. It forms these perfect, bouncy, floating balls. Plants get super confused and have no idea which direction to grow their roots. And get this, sweat and tears, they don't drip. They just pool into these thick, sticky puddles right on your skin. Plus, since there's no up or down, any wall is literally a floor if you just orient yourself to it.
Which brings us to Section 4, a universe without gravity.
Just as a quick thought experiment, if Earth magically lost all its gravity for, let's say, just 5 seconds, it would be absolutely catastrophic. Everything not bolted down would instantly begin to float. Cars would lift off the highways, the oceans would literally pull up and leave their coastlines. Our atmosphere, the very air we're breathing right now, would immediately start venting out into the vacuum of space. And the moon? No longer tethered by Earth's pole, it would just completely break its orbit and drift off into the dark.
And then, 5 seconds later, the gravity switch flips back on. What happens then? Well, everything that just floated up, the oceans, the cars, entire buildings, would violently crash right back down to the surface. It would be absolute, unimaginable global destruction. So yeah, gravity isn't just keeping us grounded, it's literally the architect of the entire cosmos. Without it, the universe as we know it just ceases to exist.
Now, because this prolonged freefall is so incredibly tough on the human body, future deep space trips, like, say, a multi-month journey to Mars, they're going to require a solution straight out of a sci-fi movie: artificial gravity. By rotating a giant spacecraft, scientists can use centrifugal effects. Basically, as the ship spins, it throws the astronauts outward toward the outer walls. The floor essentially pushes up against them as they spin. It recreates that crucial normal force we talked about earlier and perfectly mimics the feeling of Earth's gravity.
So the next time you see footage of astronauts floating effortlessly through the ISS, just tossing those perfect floating spheres of water to each other, remember the real secret. Gravity never left them. They are just falling, forever, together. Which leaves us with one final thought I really want you to ponder. Armed with this completely new understanding of orbit and weightlessness, if you could spend one day floating in endless freefall, what is the very first thing you'd do?